Let me introduce an important concept in clustering: distance. In hierarchical clustering, at each stage, you merge two clusters based on how close they are to each other. To do this, you need a way to measure the distance between clusters, and there are several ways to define this distance. Consider a simple example. Imagine we have a dataset about customers, and for each customer, we know how many euros they spent on vegetables, fruit, meat, dairy, and pet items over the past month. For now, let's ignore clustering and focus on determining which customers are closest to each other. In other words, how do we measure the distance between customers? To simplify, let's consider only two variables: vegetable and fruit expenditures. A natural way to measure distance in this case is the Euclidean distance, which is often the first approach that comes to mind. Here's how the Euclidean distance works. Take two customers A and B. Since we're working with two variables, we can plot the customers on a graph, where one axis represents vegetable spending and the other represents fruit spending. The shortest straight line connecting points A and B on this graph represents the Euclidean distance between the two customers. To compute this distance, first, calculate the difference between the two customers for each variable. For example, if customer A spent 100 euros on vegetables and customer B spent 40 euros, the difference is 60. 2. Square this difference. 60 squared equals 3,600. 3. Repeat the same process for the second variable. If customer A spent 50 euros on fruit and customer B spent 40 euros, the difference is 10. Squaring this gives 100. 4. Add these squared differences together. 3,600 plus 100 gives 3,700. Finally, take the square root of the sum, which gives you the Euclidean distance between customer A and B. This process works for any number of variables. If you have n variables, you 1. Compute the difference for each variable. 2. Square each difference. 3. Sum all the square differences. And finally 4. Take the square root of the total sum. The result is the Euclidean distance between two data points, providing a straightforward and intuitive way to measure similarity between customers in a dataset.